How is solving inequalities with addition and subtraction similar to and different from solving equations with addition and subtraction? Think about this question during the lesson. The baggage weight limit is 50 pounds for the airline that Raul is using. Raul's first bag weighs 38 pounds. How much can Raul's second bag weigh without going over the limit? Is there more than one possible weight for Raul's second bag?
Select your answer.
The limit of 50 pounds means no more than 50 pounds. There are many possible weights that are no more than 50 pounds. This symbol for less than or equal to can represent the phrase no more than. Write an inequality to represent the situation. The weight of the first bag plus the weight of the second bag is less than or equal to the baggage weight limit. Which of these quantities are known and which are unknown? You know the weight of the first bag, 38 pounds, and you know the weight limit, 50 pounds. You don't know the weight of the second bag. That's what we want to find out. Let P represent its weight. We'll solve this inequality the same way we would solve an equation. We can use the inverse relationship between addition and subtraction to isolate the variable. The subtraction property of inequality is like the subtraction property of equality. Subtracting the same number from both sides maintains the inequality. The solution is P is less than or equal to 12. We can use a number line to show all possible solutions to the inequality P is less than or equal to 12. 12 is the greatest possible value of P. The second bag can weigh at most 12 pounds. It can also weigh any other amount less than 12 pounds. The number line shows the solution of the inequality. If the second bag weighs 10 pounds, the total weight is 38 plus 10 is equal to 48, which is less than or equal to 50. How is the real-world answer different from the solution shown? In the real-world answer, the second bag must weigh more than 0 pounds. For example, -3 is a solution because it is less than 12. But you cannot have a bag that weighs -3 pounds. Now you know how to use addition and subtraction to solve inequalities.
Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester.
Let's complete the inequality. So we have 26 hours of community service completed, and it says she has to, or her goal is to complete at least 90 hours this semester. So we have to look to the right, and it says write and solve an inequality to show how many more hours H, so that variable is going to be H that we're using, Kyoko can complete to meet her goal. So the H is the hours that she's going to complete, and it's going to be adding to the 26 that she has already completed, and then it's going to right here has to be our greater than or equal to symbol. So her goal is to have at least 90 hours. So the words at least means at minimum that number. So at minimum, she wants to make or complete 90 hours. So that means she would be fine with completing 90 hours. So I'm going to just add my line here to serve as an equal, that value can be equal to 90. Now, at least is a minimum, so that means anything greater than 90 is also acceptable to her. So we're going to use the greater than symbol. I'm sorry, I went the wrong direction. Greater than symbol, because the number of hours that she completes can be greater or equal to the 90 hours for the semester. So now we're going to complete the second part where we solve for the value of h. So we have h plus 26, and then we have the greater than or equal to 90, and then we are going to get the h by itself by using the property, subtraction property of inequality. So we're going to subtract 26 from both sides of the equation. And let me do that in a different color. It's going to be subtracting 26 from both sides. And then these two will cancel. And then we're left with the h on one side of that inequality. And then 90 minus 26 is going to give us 64. And so h, which is the hours that she completes, can be greater than or equal to 64 hours. And so we found our value.
The weather forecast predicted that the evening temperature could get as low as -12 and 5/10 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7 and 5/10 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature, T, have been?
Write inequality to represent the situation. Then solve as you would an equation. So they have the inequality written for us. It's T minus 7 and 5/10. For the drop is negative, so minus the 7 and 5/10 degrees Fahrenheit, greater than or equal to -12 and 5/10 Fahrenheit. Because it says it can get as low as, so that's a minimum, so it could be equal to -12 and 5/10 degrees or greater. So that's where we got the greater than or equal to symbol. And then we solve for T. So they have used the subtraction property of inequality, addition property of inequality, and added the 7 and 5/10 on both sides. And then we have T left over on this side of the inequality, and then we have -12 and 5/10 plus 7 and 5/10 equals -5. So the T can be any number on the graph that is greater than -5, which is why they have the closed circle that represents that it could be equal to the -5, and then all of the numbers going to infinity greater than -5. So the afternoon temperature could have been -5 degrees or warmer, and then here is what the addition product inequality is again.
The speed limit on a road drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve. He never drives above the speed limit. What speed was Mr. Gerard driving before the curve? Graph the solution.
The speed limit drops down to 15 miles per hour. Mr. Gerard slows down by 10 miles per hour. He never drives above the speed limit. That's important. And the question is, what speed was Mr. Gerard driving before the curve? Graph the solution. Before we can graph the solution, so let's make our inequality. So let's make our variable, which is the speed he was driving before the curve, be g for Mr. Gerard. So we have g, and then it says he slows down by 10 miles per hour. So slowing down would mean that whatever speed he was driving, he's now going to subtract 10 miles from that, and that's how fast he was driving. Then it says, again, we underline that the speed limit was 15 miles per hour, and he never drove over that speed limit. So because of that, we know that his speed limit has to be less than 15 miles per hour, and it can also equal 15 miles per hour because it said he never drove above that speed limit. So we now have our inequality and we need to graph it. So we have 15 already on the graph, and it's closed because our value of g will include the number 15. And we also have to draw the arrow going either to the left or to the right to indicate the value of g. What could g equal? So we know it has to be less than 15, so all the numbers that are less than 15 are to the left. So we draw our arrow pointing to the left, and we have now graphed our solution.
Solve the inequality negative 2/3 is greater than x minus 1/2. Then graph the solution.
Here are the steps. We have to use the addition property of inequality and add that 1/2 on both sides of the greater than symbol. And then they cancel out on this side and we're left with x. And then we subtract negative 2/3 and 1/2 because there's a negative, so we essentially are subtracting. And then we get negative 1/6 is the value of x. And 1/6 has to be greater than x, negative 1/6. So because of that, when we graph it, the circle will be open because it cannot be equal to 1/6. We don't have that line underneath. So it has to be open so that it does not include negative 1/6. And then it's negative. So it has to be any negative number that is greater than, less than 1/6, because x has to be less than 1/6. So that'll be every single number going that direction.
Solve the inequality negative 5/8 is greater than or equal to n minus 1 3/4. Then graph the solution.
We need to make sure we're isolating the variable n, so getting it by itself. So we are going to add the negative 1 3/4 on both sides of the equation. So that's 1 3/4. So we're going to add on both sides. Excuse my handwriting. And then these cancel out, and we're left with n. And then negative 5/8 plus 1 3/4. Let's see. Because we have fractions, we're going to have to make the mixed number into an improper fraction. So that's 4 times 1 plus 3 is 7. We're right over here, 7/4. And then we have minus 5/8. So now we have to make sure they both have the same denominator. So it'll be easier to make the 7/4 have an 8 because that's a common multiple. So that will now become 14 over 8 because 4 times 2 is 8 and 7 times 2 is 14 minus 5/8. That will equal 14 minus 5. Our 8 will stay our denominator, and then 14 and 5 will give us 9. And so now we have the value of n is greater than or equal to 9/8, which is, we have to make it go back into a mixed number. So 8 goes into 9 once. That's supposed to be minus 8. 9 minus 8 is 1. So we have 1 as our whole number. We have 1 as our numerator and 8 as our denominator. So now that's the value of n. Now we have to graph it. So because there is a greater than or equal to symbol in our inequality, our point is going to be closed, and then it's going to be closed on 1 and 1/8. 1 and 1/8 would be about here. It will be about here, and oh, that's very big. It will be about here. And then it has to be greater. Is less than 1 and 1/8. So it'll be every number that is less than the 1 and 1/8. So it'll be a closed circle because it's going to be less than or equal to, n is less than or equal to the 1 and 1/8. And then everything less than is going to be that direction. So we've now graphed our solution.